Hey, this is Lance from LangChain. So Anthropic just released tool use through their API, and I've been really excited about this for a while. So let me kind of walk through the implications and how it works. So first, all you need to do to get started is just pip install LangChain Anthropic. And I want to talk through how this is really useful for structured outputs. So let's just kind of talk through it. How can we use tools to produce structured output? I kind of think about tool use or function calling as kind of interchangeable terms. And the point is, it basically invokes the LLM to produce a payload. Now, this payload is usually a JSON string. It can be passed to an API, like web search, for example. It could also be passed to a parser to produce a structured output, like we're going to show here. So LangChain has this with structured outputs method, which basically binds tool use for structured output generation to an LLM. You pass in a schema, and you get your object out. So let's actually walk through what happens under the hood. You have a schema. Let's say we're doing code generation. We want the output to have three things: a prefix, a code solution, and imports. Okay, we can define that as a pedantic object with that particular schema. We pass a question. This object is converted into an internal function schema, which is basically like a JSON, which is then plumbed to the LLM. So the LLM knows about this function or this tool that it can invoke. So it gets the question, it ideally invokes the tool, that returns a JSON string. We also, using this method, take that object you define for your output schema, and we create a parser from it. We parse that string to the output. That's the flow. So let's just show how this works. A couple easy imports. Here's our data model, right? We talked about that code schema we want, prefix imports code, all strings. We kind of describe what it actually is. Now, here's our LLM. We're going to use Claude 3 Opus, and this little header just indicates that we want to enable tool use. So again, we call the LLM with structured outputs, and we include, or we plumb through, the schema we defined right here as code. And I'm also including this include raw flag, which will basically, you'll see, returns both like the raw model output. So you can kind of think of it as this thing. It returns that, and it returns the parsed output, and it returns any parsing errors. That's a very useful trick. So let's kick this off. This runs. It may take a little bit. We're using Claude 3 Opus, so it's the most performant model. And we're just asking a simple question. Write a Python program that prints a string, hello world, and tells me how it works in one sentence. So in this case, I can see kind of the raw output. You'll see something interesting. Initially, Anthropic does this thinking step, which it kind of reasons about the question. Then Anthropic, you can see here, this is actually the tool call. And so if you look at this, here's that JSON string, prefix code imports, like we had talked about above. So that's pretty neat. You can actually look at this raw intermediate object, which is this thing, and see that intermediate JSON string that the model is returning. Then we go ahead and see, hey, were there any parsing errors? We see no. We can then fetch out that parsed result, and then there it is. So this is pretty cool. There's our parsed result. Now this is the pedantic object we want out. That's really it. That's showing everything working end to end, which is really cool. And you can see we kind of did that all in like 3 minutes. Let's look at more challenging examples. This thing I've actually been working on quite a bit is code generation. I have a bunch of different LangGraph code generation flows that typically involve some kind of inline or in the loop unit tests. So what I want to do is I have a code generation step that'll answer questions about some set of documentation like context stuff. Typically could be LangChain docs or other docs. But what's interesting is I want the output to be this pedantic object of like a prefix, imports, and code, just like we saw above. And then I can apply unit tests. So this is like a real world motivation why I care about this and why I've been using it quite a bit. So I'm going to load those docs right here. And so this is just loading, for example, some documentation from LangChain. And I'm going to show you something pretty cool here. Let me just kick this off, and then I will go back and explain to you what's going on. So here's a problem statement that's really common. You see how above here, we are counting on the LLM to invoke this tool, but that's not always guaranteed. So what we can do is, note that in this output we get this error, so parsing error. So if there's some problem with the tool invocation, and this intermediate object that our parser attempts to parse is not parsable, like, for example, what if it didn't call the tool, so then it doesn't return a JSON string, it just returns like a blob of text, it can't be parsed, you'll see an error. we want the ability to kind of catch that and retry. So let's just show how to do that. It's a kind of a really nice little trick here. And we'll do it in a more challenging case. So this is actually, I'm loading a bunch of LangChain expression language docs. I have a code generation prompt that basically loads all those docs into the context window. And includes some stuff like your code assistant with expertise in LangChain expression language. Here's a bunch of documentation, answer questions, right? So this stuff is same as before. Define my output schema. In this case, I add a description. This is the schema for code solutions related to LangChain expression language, which tells the LLM a little bit more about the tool. Same as before, same as before. Now, here's where I can do something pretty cool. Remember that the model output is basically a dict, and it has that parsing error field. So what I'm going to add is a little function here. So if the output has a parsing error, I can fish out both the raw output and the error, raise a value error, and then I can just return the tool output. So here's a trick. I now build a chain which has our prompt, our structured LLM, and this little check. That's the new thing. Now what I can do, LangChain has this really convenient thing called with fallbacks. So basically, I can define a fallback chain, which is basically just this. So basically, this check occurs. If this check throws an error, I can go to this fallback chain, which sucks in the error and basically automatically retries. And so I can implement that all here, where this is my code chain. So we define that up here. That code chain has this check at the end. And I have this fallback chain. If that check trips, I go to the fallback and I basically add messages to the LLM saying, hey, you're required to fix the parsing errors. Here's the error that you got back. Try again. So it orchestrates that feedback. So I can call code chain with fallbacks. I add the fallback chain here. We just ran that. And let's see what our output looks like. So we can actually see. Here's how to write a RAG chain using LangChain expression language. Here's the imports. Here's the code. Hopefully the code executes. Okay, and so there's a pip install that I need to do. That is something that I would actually catch more in unit tests. But in any case, you can kind of see that at least the Pydantic object was correctly formatted and returned. So that's a really nice trick if you want to enforce the output schema. You can use this kind of fallback to catch errors in Pydantic validation or Pydantic parsing, and to retry. Nice little trick there. And again, the error we saw down here is a really good example of what I see often when I'm doing kind of code execution in the wild. That's something I would catch in my unit tests. So I would attempt to execute the imports. If those fail, I can retry the entire process, or I can check the code execution like we just did and retry there. In this case, that retry loop would include, hey, your code's missing something. You don't have this package, pip install, this guy. And then my code execution would include that as an additional thing that is necessary. So, for example, if I was running this in a sandbox environment, I could then run that pip install and it would update my environment and then it would run. So, nice example showing how to use Anthropic with structured outputs, like the vanilla case, simple case up here, and how to do it with this kind of retry fallback. If there are validation errors, you can use what we talked about here, this with fallbacks, to basically catch any validation errors from tool use and to loop back and to enforce that the tool is actually invoked. So that's about it. Hopefully this is useful. Thanks.